And while this is doing its thing here, microprocessor after. Let me, instead of wasting time, let me do this in the background while we're. Okay, all right. Unfortunately, okay, all right. Getting back to where we were at here, out there. If I wanted to do something here, let's say I wanted to add some numbers together, right there. I just wanted to add, up there. Let's just move before we get into this here. Let's move into B. 0, 0. And what we want to do at this point here is that I want to add some numbers, and this is where things get kind of messy, is that we have to move things around. We have to have A stored if we want to do a loop of 10. That there. But let's just simply say add BA. Let's see if that will work. No, it will not let me add right there. So if I want to store that, we have to do a move to R0A. Right there, store A, add A, and I'm just going to say we moved A to that there. Move R1, A back for R1, right there. No, we didn't. I want to do a move here. What I'm trying to do is just show move at there, and then we want to add a R0 right there. And then move A back to R1 and move A back, I'm just throwing various ones here, R1A and move A R0 right there. And I'm just moving things around, but I'm storing moving R1, I'm storing R0. Ignore everything there. I move A to R0, and then I move R0 back. And I'm adding R0 to A. But regardless, what I'm doing is I'm saving R1. But I need to save R1 the accumulator, and move it back. So if I want to use the accumulator to do any adding, I have to store it someplace and move it back. It doesn't matter where we're at. Let's just put it in R7 just so. Right there. So again, all we're doing is we're just storing everything here. I do doesn't matter. I can do whatever I want in there. But the top thing is I store the accumulator and then I restore it back. So I can use the accumulator for whatever I'm wanting right there. So let's compile it and assemble it. Download it. Again, let's put the break here. Right there. All right. As we go through this here, step 1, we move 10 into the accumulator. Next one, we move 0 into B. Then we move R7, the contents of the accumulator. We just do a bunch of other junk here. We don't care what we're doing. But eventually we move R7 back to the accumulator, right there, and we decrement it. Right there. We jump back to our loop here. We store the accumulator again into R7. We do some other junk. We've moved we move the 9 back into the accumulator, we decrement it, and we jump back. We keep doing this right here. You know, and we see that we're still going through the 7. You know, now it's 6, 5. You know, again, you're seeing the accumulator change, but it always gets restored back. And we decrement it there. You see the accumulators get done, all kinds of things, and we accumulate, and we got back to 0. So we exit our loop. But what I had to do here to use this loop, you notice that I had to add this line here, and then I added this line here. You see those 2 lines I added there? The reason is I have to use R0 if I'm going to use the jump, not 0. I have to use R0 right there. And so if I have to use the accumulator within my loop, I have to save it someplace. So in this case, I saved it where? R7, right? So I've saved the accumulator, and then at the end of the loop, here, I moved it back. Here I save R7, or save the accumulator in R7. Here I store it back. Everything in here, I don't care what is there. I can put all kinds of stuff in there. I can use the accumulator, or I can do everything. As long as I don't touch R7, I'm going to put it back. If I mess with R7, then I broke my loop. Right there. Now, as it turns out, I can use this command right here, and I can take this one out. Because this command here actually does a decrement and jump not 0 and 1. I combine the 2 steps. And this is going to behave exactly the same. Oh, it did not like that jump. Decrement. Jump. That looks right. Loop 1. Oh, no, I can't do that. The reason is I forgot to put the A there. That's what I forgot. Oh, still didn't like that. Why doesn't it like that there? Decrement, jump, not 0. That looks like it's valid. What did I break? A comma. That's right. Sometimes when I get to this right here, let me see what I broke. If I broke it, I broke it. Jump not 0, R7. Yeah, see, yeah, that command looks right. I didn't break anything. Loop 1 is right. That worked. All right, I broke something else. What did I break? Well, view, output window. One error. Number of operands, line 78. Oh, this is what I broke here. Is that there? Yeah, that worked fine. Okay, that one works fine. Now, as it turns out, looking at this assembler, I've never done it this way, but it looks like we can use registers there and use the decrement. right there. Let's try using a register that there. It looks like it's that there. Let's move into R5, 10. We don't care about any of that stuff here. Decrement, jump not 0, R5, loop 1. Okay, that does work. So you can use the R there for your loops. That there. So let me just show you what I did that there. Let's put my break in here. In this particular case, I'm moving into R5, my 10 right there. And I'm running my loop here, right there. I don't care what's going on in my loop. Here I'm going to decrement from R5, 1, and then I loop that there. And as I go through R5, will change. 7, 6, 4, 3, 2. Next time it should be a 0. It's 0, and notice that I jumped to the next one there. So you can use the R0 through R7 for loops, but you can't use the decrement and follow it with a jump not 0. You have to use this command here, the jump not 0. Decrement jump not 0. That will work. That may actually work with B too. Here I'm not using B. Let's just put a 5 in B in this right here. I'm just trying some different things here. B is 4, B is 3, B is 2, B is 1, B is 0, and it works. So you can use, so the answer is yes, you can use B, but you can't use it with the decrement follow with the jump not 0. You can use it with the decrement jump not 0 as one command. Not there. So you can do it that way. So that's kind of an overview. As I said, I wanted to spend about an hour kind of showing you how this works with the debugger. I don't know if any of you were able to follow along. I'm going to stop here and let you guys kind of just try some different things here. There's nothing turning. The whole idea is just to see how you can see the memory over here. Again, the memory you see on this side here. Yes, you have a question? That there. But this is kind of the way that you will go through, because what you're going to, I'll be honest, if I'm going to write a final exam question on this, what you're going to do is you're going to be given a piece of code, and you're going to be asked what will the registers contain at certain points, right there. And I'll go through some examples of that on Tuesday or on Monday, of the type of test questions I would ask going through this type of process. Because you're going to be given a piece of code, and I'll say with line numbers shown, I'll say at line 23, what will the accumulator contain? Well, at line 29, what will the B register contain? So you have to kind of know what's happening with these instructions right there. So in this case, we've added there. The one thing I did not do is I did not set up an array and walk through how you would add up 10 numbers in an array. We will do that at a later time, right there, where we would set up an array and point to the use that to point to that there. So, but this kind of shows you. Let's go back to the slides here a little bit and kind of see which ones I haven't covered right there. No. Right there, as we go through and we look at slideshow, current slide, we went through again the registers. We did the direct, I showed, I didn't show the R0, but let me do that one real quick, this indirect. The indirect one is fairly easy, is right here. We're going to move R0 35. Let's use 35 here in R3, and I'm just going to then move the address at R3, the number 99 hex right there. That's all I'm going to do. So I put in R3 25. And it doesn't like that there. Let's go back to my slides. If it doesn't like that, I'm doing something wrong here. View output window. Two errors. Bad register, indirect. It doesn't like move 99 to the location. Right there. It does not like that there. And it still doesn't like that one there. Bad indirect. R3 does not like going in that direction. And I'm doing something wrong. You can tell I don't write assembler very often. Move contents of R3, it goes this direction. It may not let you go the other direction. You know that right here, move stored contents of the accumulator pointed to by R3. Should have an 8-bit address, such as right there. That's exactly what I've got right there. And R3 contains 35 hex. Okay. I'm not going to fight with this very long, but that looks fine. R3, A3. Move. That looks exactly like what I've got. Right there. Move. And there's the capital shouldn't make any difference. And two errors. Error number 89 in line 67. Move A. Add indirect A number A4. Well, it does not like something I've got there, and I don't know what I'm doing wrong, because that looks exactly like what this command right there. That should work. Right there. Move. Oh, right. I'm sorry. I missed that one statement right there. Everyone see the gotcha? Only R0, R1. I cannot use R3. That's the gotcha. I got that there. So I can use R1 right there. That was a mistake I made there, R1. As you can see, some of these commands out there. Yeah, you see now it. I'm just going to single step through here. Let me close this door. I knew there was something obvious I was missing. Move 30 hex, move A, 35. So I'm going to move 25 into R0, 35 into R1. A contains what? A contains 35 at this point. And I'm going to move that to location 35. So if I go to 35 on my location, right there, there's my 35. So there's where I did the move right there. Let's step through this again. That's my loop there. And you won't see anything that there, but again, that's the gotcha, and that's what makes assembly language programming very interesting. And that's one of those things that you saw me make that mistake, and it wasn't, you know, sometimes, to be honest with you, I've done those, and I've spent half an hour reading the manual before I caught that little glitch. And that's not something that you're going to run into in a basic circuits course. This is something, because this microprocessor is designed by a human being, and they put restrictions on that don't necessarily make sense. That there, in this particular case, our restriction from the data sheet tells me that indirect addressing, this uses a pointer to hold the effective address of the operand. Only registers R0, R1, and the data pointer can be used. That's one of those, I didn't remember that. I'm sitting there going, that looks exactly right. What's wrong? Why didn't I get that? And then, you know, you look at the data sheet and guess what? Why doesn't it work? And my assembler error just said there was something wrong with that command. It won't work. Right there. And it looks exactly right. And right here, we missed one. Good test question. What registers can be used for indirect addressing? Even though I didn't remember here at this point, but right there, this is one of those things that you caught. You know, you saw me go through 2 or 3 times looking at, figure out what's not right, what's not right, what's not right. Went back and looked at the notes, and I caught that there. All right, I said I was going to talk about an hour. I'm going to be quiet here. And I'll let you. Right there, I'm going to stop this and.